Alright, so today we continue on with lesson 6.6 part 2. Pause the video and read the problem of the day and solve it. Think about what could the student have done to avoid the situation that they did, the problem. Alright, so what we looked at the beginning of 6.6 in the last video was raising it to an exponent power, like you had a square root or a cube root or a fifth root, something like that. Now we're going to take a look at rational exponents because it's also one thing that we talked about in this chapter as well. So there's 3 steps to solving these. Number 1, isolate the terms attached to the exponent. 2, raise both sides to the reciprocal power to eliminate exponent. And 3, solve using PEMDAS backwards. So it's the same thing that we've been doing with actually the other part of this lesson. All right, so if we look at letter A, 4x to the 3/2 power equals 108. Step 1, isolate terms attached to the exponent. So we have to get rid of what? The 4. We only want the variable with the exponent. So we're going to divide both sides by 4. So you get x to the 3/2 equals 27. All right. So we isolate the term. Step 2, raise both sides to the reciprocal power to eliminate exponent. What's my exponent here? 3/2. So I'm going to raise it to the 2/3 power. But you could see that there. And why we do that is for the fact that 3/2 times 2/3 cancels out, it equals 1. So these actually cross cancel, right? We're left with just x to the first power, or x. 27 to the 2/3 power is 9. And that's our answer. All right. So let's take a look at B. If you see, I have x minus 4 quantity to the 2/3 power minus 9 equals 16. This exponent, or rational exponent here, is not isolated yet. We have to add 9 to both sides to get it by itself. So if I add 9, 16 plus 9 is 25. Now, remember, we do not want to distribute the 2/3 power to both parts. The only way we can solve this is to take it to the 3/2 power. So the exponents cancel out. So 3/2. We now get x minus 4. Now when you take the power here, here's what's going to happen. There's a plus minus here. Now I'm going to explain why when we solve. Do you see that this is a 2 here? There's a plus minus because you're taking a square root. Here, what was it in the bottom? This was odd, right? Odd, there's only one answer. But because of the even, there's a plus minus here. Bring the negative 4 over as a positive in front. So we have 4 plus minus 125. 4 plus 125 is 129. 4 minus 125 is negative 121. So you get 129 and negative 121. All right, let's look at the next one here. Multiply by the reciprocal, negative 3/2 power to both sides. We want to isolate that variable. So this goes away. Of x to the 1/5. equals 3. And raise it to the 5 over 1 power, or the 5. And get 243. And that's my answer. All right. So the next part of the lesson deals with extraneous solutions. And let's take a look here. It says, solve and check for extraneous solutions. So we're dealing with square roots again, or roots, and rational exponents are mixed in. But if you take a look at a root, in order to undo a square root, you square it, right? Now look what you notice here. This is a quantity squared, which is the same as saying this twice. And I want you to write it out. I'm going to have to FOIL. So FOIL the left hand or the right hand side, get x squared minus 8x minus 8x plus 64. And we'll bring everything over to the right. The x from here becomes negative x. Then I brought the negative 6 over to the right as a positive 6. Now we're going to simplify. What you're going to notice here, we get 0 equals x squared minus 17x plus 70. We're going to actually have to factor it. So you go back to factoring. We get signs are the same, they're both negative. We want 10 and 7 to get 70. Seven times 10 is 70, negative 10 minus 7 is negative 17. So I have two answers for this. I get what? 10 and 7. Now it says check for extraneous solutions. I think I might actually type them out. I actually have to go back to the original and plug them in. Because sometimes one will work, sometimes none will work. So I'll try 10 first. Don't forget this is a square root here. And maybe I'll write it. 10 minus 6 is 4. So remember, we plug it back into the original. 10 minus 8 is 2. 2 equals 2, which is correct. So 10 works. Then we're going to plug 7 in. Square root of 1 equals negative 1. So what do I get here? I get 1 equal to negative 1. That is not true, right? So actually, I could omit 7 from my answer. The only answer here is Sometimes one will work, sometimes both, maybe none. All right, so you do have to take a minute and check your final solutions to go back in. All right, so we're doing a little review here. Let's talk about the next part of the lesson, FOIL with radicals. So multiplication with the same root, square root of 2 times square root of 2, and multiply like roots. Square root of 4, square root of 4, it's 2, right? All right, let's try B. Get what? Square root of 100. Which is 10. All right. Addition of roots, square root of 2 plus square root of 2. Don't forget, it's 2 root of 2. We have to have the same root inside or the same number inside the root, same root. We add the coefficients. There's really a 1 here and here. And then that would give us what? 5 plus 5 is 10. Root of 10. The reason why we're going over these is it's going to help us to when we have to FOIL or multiply some of our other problems. All right? Now what if we looked with variables here? We'd get what? This is 2 root of x, right? Here this is square root of x squared, which they cancel out, right? So if you multiply by the same exact root, the root goes away, you get the answer without the root. So if we get this, think about what the shortcut to this one is. I mean, I'll write it out first. X plus 2 squared, which is just x plus 2. Now, while we're looking at this, if we go to the next one, I want to talk about FOILing something. And if you notice with examples 5 and B, with the little tail end on the root, you are FOILing. Not everything is inside the root, so it's not like this will just be x plus 1 because it cancels out. You actually have to multiply it out twice. So let's take a look at how we FOIL these. All right, first, square root of x times square root of x. Remember, square root of x times square root of x, it's the same thing. You get square root of x squared, or just x. All right. Outer plus 1 root of x. Inner plus 1 root of x. Last, 1 times 1 is positive 1. Now, are we okay with how I got that x again? If I write it off to the side, just like the last one, I sort of do it as a shortcut. I don't show my work. You get square root of x squared. Lo and behold, that's how this becomes an x, right? Square root of x squared, they cancel each other out. All right, so now we could combine the OI of FOIL. That's my answer. X plus 2 root of x plus 1. All right. I want you to pause the video and try the next one. I want you to try it yourself first, then I will do the work for it. All right, so for this one, as you can see, we write it twice. First to FOIL is square root of x minus 2 squared plus outer 1 square root of x minus 2, inner plus 1 square root of x minus 2 plus 1. Now we're going to combine. We're going to simplify this piece here and then combine like terms. So why don't you try that? So square root of x minus 2 squared is just x minus 2. Then we add these, plus 2 square root of x minus 2 plus 1. What you're going to notice now is I could also combine. Do you see how it's a negative 2 and a plus 1? We're going to combine like terms one last time. So there's nothing that'll combine with the x. It's just an x. Negative 2 plus 1 is negative 1. And plus 2 square root of x minus 2. That's my answer. Now you might be saying, well, why So you might be wondering, why do we do examples 4 and 5? Why are we foiling? Why are we multiplying out? Well, what if there's a problem that you solve algebraically and it's not all contained inside the root? So here's to our last example. Solve and check for extraneous solutions. And once again, here's your little tail end here. I like to actually draw it so you can see. So everything on the left is contained inside the root. Square root of x plus 6 equals square root of 11 minus x is all in the root, but not the minus 3. So you can't get away with trying to get both roots on the left. That's not going to work. There's always going to be that negative 3 that's outside of it. All right, so we square both sides again. On the left, we just have x plus 6. The root goes away here. Be careful with this one. We have to actually write it twice. So it's 11 minus x minus 3. Minus x minus 3. All right. So now we're going to FOIL. Here's where that foiling comes into play, like we saw in the last two sets of examples to get us ready for a problem like this. All right. Now I'm going to do the shortcut at this point. I know when I do first a FOIL, they're the same thing inside the root. Without writing it, I know the root's going to cancel out. It's just going to be 11 minus x. And hopefully you're okay with that at this point because I showed you the other ones. Then we do the outer, negative 3 square root of 11 minus x minus 3 square root of 11 minus x. Negative 3 minus 3 is negative 6. If you're okay with me doing an OI of FOIL, 11 minus x inside the root. So I did the OI together. And the last negative 3 times negative 3 is positive 9. So I evaluated FOIL, combining the OI here. Now, let's see what else we could simplify. (11 plus 9 is 20 minus x minus 6 root of 11 minus x. Now you'll notice here that I just combined was the 9 and the 11. Now here's what's going to happen. I am now going to take these two pieces, move them over here. I want to isolate the root again. I got rid of one root from squaring these, but now I got to get rid of a second root. All right, so get x plus x, and you see where that comes from, right? The negative x comes over as positive x plus 6 minus 20. And if you notice, minus 20 comes from bringing this 20 over to the left, equals negative 6 root of 11 minus x. I can't do anything with the minus 6 yet because it's actually attached to that root. So what do I get here? 2x minus 14 equals negative 6 root of 11 minus x. Now we want to isolate the variable, so I can divide by negative 6. Now it doesn't always work out nice and neat, so what you're going to see I do is I keep it as a fraction. They go away. What you could actually do now is square the square root. So I'm actually going to square this whole big thing, every single piece inside. All right, I know this is a little complicated, so just bear with me as we solve it. I'm able to square it once again, so this side is just 11 minus x. We have to square the top, which is the same as doing this. Twice. FOIL it again. And don't forget we're squaring the bottom. Negative 6 squared is a positive 36. Finally, The right-hand side is just 11 minus x. How come? Because we squared the square root, FOIL the top,
That's a good little desk.
so I FOILed the top. Now, next part is we're going to get rid of the 36. And how I could do that is I could times both sides by 36. Promise we're almost done here. Do a problem like this, you're good. You know everything else here. Your algebra skills are really, really good. So if I times that, here's what I get. I distribute 36 to both of them. And I'm finally almost finished, I promise here. What we have to do is we have to move everything over to the left, set it equal to 0, and factor. So now this is really complicated because, you know, in the first step we got rid of the first root. Then we had to keep on solving algebraically and square again to get rid of the other root. I actually think it might be easier if I type this. So let's see, 4x squared minus 56x plus 36x, because the 36 came over as a positive, plus 196 minus 396 equals 0. Let's simplify here. 4x squared minus 20x minus 200 equals 0. If I factor, you're going to have to guess and check factoring. But what do you notice here? Do you see how 4, negative 20, negative 200 are all divisible by 4? Factor out of 4 first. Make it easier for us to solve. Now, we have no guess and check. Ten times 5 is 50. Signs are different, right? Negative 10 plus 5 is negative 5. We know when we solve, we're going to get 10, negative 5. And we know, too, that the 4 goes away because 0 divided by 4 is just 0. So these are my solutions. We have to do the check. So check goes back in. Last thing, check into the original. All right. So 10 plus 6. I'll add my root in a second, since I'm writing it out. Evaluate from the original. Square root of 16 is 4 equals square root of 1 is 1 minus 3. 4 equals, sorry about that. 4 equals negative 2. It's false. So actually 10 is not a solution. We do have to check the other one as well. Probably just do it here. See that there, hopefully. I'll just do it here. I'm actually going to just jump down to the final answer. You should get 1 equal to 1. Make sure you can get that. Like I said, we have to check both. Sometimes one works, sometimes both, sometimes none. So in the final answer, -5 is your final answer there. Only one solution works in this case. Okay, so for the last part here, if you take a look, there's 4 extra practice problems. I'm doing things a little different. I want you to work on these instead of problems in the packet. I know if you print out the notes, this last slide is going to be different. So correct this number 2 here. Do the problem of the day, and instead of problems in the actual homework, I want you to complete the extra practice problems of the previous slide here. So that means, once again, these 4 problems. All right, that's it for today.